Welcome back, everyone. In this video, we're going to talk about generative AI, and we're going to see a few terminologies that we need to know in order to begin creating AI applications. So let's see, what are we going to talk about in this video? We're going to touch on what is AI and what is generative AI, what are large language models or LLMs. We're going to talk about prompting and prompt engineering, tokenization, and temperature at the end. Let's start with what is AI. As you probably know, AI, or artificial intelligence, refers to the simulation of human intelligence in machines or computer systems. It involves the development of algorithms and models that enable machines to perform tasks that typically require human intelligence, such as understanding natural language, recognizing patterns, learning from experience, and making decisions. A couple of examples of AI applications are AI in self-driving cars, like your Tesla, that can go on autopilot. For medical imaging analysis, so AI can help doctors read EKGs reports or any type of reports. But they're also used in banks or a lot of businesses to detect fraud detection. So if they see any abnormalities in your transactions, AI can alert you and your bank as well. So what is generative AI, which is what we're going to be working on? Generative AI refers to a category of artificial intelligence systems that can produce new content or data similar to what they were trained on. These systems are capable of generating outputs such as text, images, music, or even videos based on patterns and structures learned from large datasets. A couple of applications that you're probably used already are OpenAI ChatGPT, where you can access over your browser or maybe download the mobile application. For Google, we have the BART, which is another application that you can also use made by Google. And for Microsoft, we have Bing as well, which you can access on Edge, or you can even also download it on your phone. So what are LLMs, or large language models? A large language model specifically refers to an AI model trained to understand and generate human language at scale. Large language models are typically built using deep learning techniques, particularly transformers, and are trained on massive text data or a large data set. These models can generate coherent and conceptually relevant text, perform language translations, sentiment analysis, question answering, and other natural language processing tasks. So we can build chatbots that can talk to humans and do translations and many other tasks as well. Examples of large language models include OpenAI's GPT, or Generative Pre-trained Transformer, and a few models. We have the GPT-3, GPT 3.5, and GPT-4, and we're going to see the updated list later on of the different models that OpenAI has available at the moment. A few other examples of large language models. We have AWS have the Titan, which is used in their generative AI Bedrock application or service that you can use. We have BERT by Google, and they use BERT in their BART application, very similar to what AWS offers. And then we have Turing and NLG by Microsoft, and this one is used in many Microsoft services, from Azure Cloud Services to even Microsoft 360 or Home Office as well. So across many applications in Microsoft. Let's see what is prompting and what is prompt engineering. So prompting refers to providing the model with an initial input to generate desired outputs. Prompting allows us to control and tune the output of the LLM, allowing us to influence the content, style, and tone of the generated text. So prompt is the initial text that we're going to provide to the LLM, and this is how we tweak and modify the responses that we get from the LLM. Specific prompts empower us to generate text tailored to our needs, preferences, or application requirements, spanning creative writing, content creation, conversational generation, and beyond. Here's a high-level example of how does prompting works. So first, we're going to start with a input prompt. A input is provided to the LLM, which serves as the starting point for the content. This could be a question, a sentence, or just a few words. So we're going to type a prompt, which then is going to go to the LLM. And based on the input prompt, the LLM generates text or content that follows the provided context or theme. After the LLM generates the results or the content, then we're going to have the output. And the output is going to be the generated text that is returned as the output of the model, completing the text generation process. So this is the 3 steps that we are going to talk a little bit more about in the next slides. Prompt engineering. Prompt engineering refers to the process of designing and crafting effective prompts to control the behavior and output of LLMs, particularly in the context of language generation tasks. It involves carefully constructing input prompts that guide the model to produce desired outputs that align with specific goals, styles, and constraints. Prompt engineering encompasses various techniques and strategies to influence the behavior of AI models, such as: first, we have providing context. This technique involves creating prompts that provide relevant context or information to guide the model's understanding. Here we have an example prompt. You can give the LLM the following prompt: write a short story about a detective solving a murder mystery in a small town. So we're providing context to what we want to generate. The next techniques is specifying constraints. This technique involves incorporating constraints or directives into prompts to guide the model's output. In the example prompt here, we have the following prompt: generate a 100-word summary of the given article on climate change, focusing on the impact of deforestation on global temperatures. So here we give the model some constraints, the topic specifically on what to focus, and how long do we want the summary for. Fine-tuning. This technique involves iterative redefining and adjusting prompts based on the model's responses to achieve desired outcomes. In the example prompt, we can write: generate a product description for a new smartphone with innovative features. And then we can review the generated text and provide feedback for improvement back to the model. Simulating creativity. This technique involves designing prompts that encourage the model to generate creative, diverse, or unexpected outputs. The example prompts you can write: imagine a world where humans have the ability to fly. Write a short story exploring the societal implications of these newfound abilities. So you're giving the LLM a imaginary world and what to write and to what to focus on as well. So we're simulating the imaginary world. Another technique is controlling bias and sensibility. This technique involves crafting prompts to mitigate biases, stereotypes, or sensitive content in the model's outputs. In the example prompt, we can write an essay discussing the importance of diversity and inclusion in the workplace, highlighting strategies for creating a more inclusive environment. These examples demonstrate how different prompt engineering techniques can be applied to shape the behavior and output of generative AI models accordingly to specific goals, requirements, or ethical considerations. So with these techniques, we can shape the output that the LLM will generate. And this is very important because we need the better prompt that we write, the best content is going to give us back as an output. Here we have a few examples to compare now. So a good prompt would be write code to calculate the Fibonacci sequence. That's a good prompt. It's okay. You can start very basic, and then you can look at the output and then rewrite your prompt to get a better output. So a better prompt would be write a TypeScript function. So we specify in the programming language to effectively calculate the Fibonacci sequence, comment the code literally to explain what each piece does and why it's written that way. So we specify in the programming language, which allows it to be a efficient function, and to comment the code of explaining what the code is doing. This is a better prompt. We also have another good one here. So let's say summarize the meeting notes, and we can provide the LLM with the meeting notes, and it will generate a summary. A better prompt would be summarize the meeting notes in a single paragraph, then write a markdown list of the speakers and each of their key points. Finally, list the next steps or action items suggested by the speakers, if any. So you don't have to worry to just create the perfect prompt at the beginning. Just create a simple prompt and then look at the output, rewrite your prompt, look at the output, and just keep making your prompt better, and better. So we're going to practice how to generate this practice. This is also online. There's tons and tons of different resources that you can read and get some example prompts as well. But it's good to just give it a try, and we're going to jump into a playground where we can type some of those prompts in a few more slides. So we're going to go to the playground and on this website to try some of those prompts. And also this is the link to the OpenAI docs on prompt engineering if you want to read more. I gave you kind of like a high level explanation of on some of those topics, but I recommend going in there and reading some more about the prompt engineering techniques and all the options that you have available. But we're going to see more in the next videos where we create the different applications. A tip here is continuously evaluate the effectiveness of your prompts based on the model's responses and adjust them as needed. Solicit feedback from users or stakeholders and iterate on your prompts to improve their effectiveness over time. So like I said, start small, get some feedback, and reiterate by creating more specific prompts. Before we jump into the platform, we're going to finish up a couple of more slides so we can understand tokenization and the temperature, which we're going to play with that in the playground. So tokenization is the process of breaking down a piece of text into smaller units called tokens, which can be words, subwords, characters, or symbols. This process involves segmenting the text and assigning a unique identifier to each token. Tokenization is a fundamental step in a natural language processing or NLP task, enabling computers to understand and process human language effectively. So this process is going to happen automatically depending on the LLM that you're using. It's just that we need to be aware of this process because we are going to maybe run into some problems later on. So a high-level example of tokenization is when we provide an input or a prompt to the LLM, the text will be calculated as token. So depending on the tokenization technique that the LLM uses, is going to break down your prompt into sections, subsection, characters, and is going to calculate them into tokens. So the LLM will have a limit amount of the tokens it can input and output from the model. So if we ask for too much text, we might end up with some errors, and we need to be aware of the settings. And we're going to practice that in the playground as well. Then we're going to get the output, and the output text will also be counted as the total tokens. So you need to calculate the input text and the output text that you want, and you got to make sure you don't go over the limit that is set for this LLM. And depending on the LLM that you're using, if you're using GPT-3, GPT-4, the limit will be different. In the context of ChatGPT or any similar language model, the term tokens typically refers to the individual units of text that the model processes. These tokens are generated by the tokenization process. Token counts depend on the tokenization method used. For simple word-level tokenization, the number of tokens is roughly equivalent to the number of words in the text. So each LLM will give you kind of like a rough amount of, how many tokens per word or per depending how much text you give it. A general average for a OpenAI GPTs are one token per 4 characters. That's just in general throughout the different LLMs, but each one will have a specific technique. We're going to see a list of the amount of tokens that each LLM can process. So keep in mind that these estimates are rough approximations and may vary depending on factors such as the language that you're using, English, Spanish, French, whatever language you're using, the writing style, and tokenization method used as well. Additionally, the number of tokens may be influenced by factors such as punctuation, special characters, and white space handling. So maybe special characters are going to count, white space can count. So we need to be aware of this just to make sure we have enough tokens to process the amount of text or generate the amount of context we want. So a high-level example would be we can give a prompt to the LLM and say, finish the following sentence. And we say, my favorite. So we're telling the LLM to finish your sentence here. What the LLM is roughly going to do is going to get your beginning of the sentence and it's going to predict what is the next word that it might follow your prompt. So you can say my favorite, and it predicts that the next word could be food, and it will generate this, and it's going to add it to the beginning of your prompt, and then it's going to run that again, and it's going to see what's the most probable next set of characters or words that is going to go. So it predicts that it's going to be after my favorite food is going to be is A, and it's going to add this to the prompt here. It's going to run through it again, and then let's say it predicts that the next word is going to be pepperoni, and then it's going to add it to the prompt, run it again, and it's going to predict that after pepperoni, you're of course going to say pizza, right? So it's going to give you the output. My favorite food is a pepperoni pizza. So this happens behind the scenes, and for each prediction, this is going to generate a token. So it could be 4 characters, it could be a few words, it could be a different amount of characters or words depending on the LLM that you're using. So we just need to be aware of the kind of like the limit of tokens, but we'll have to play around with the LLM to see the amount of text that we can produce. And this output is per prompt. So if you tell them to write an essay about something, and we can only produce a 1,000 words essay, that's the limit for the LLM, and that's how much text as you can get for the prompt. So a little bit about tokens. So the token limit is an important consideration when using GPTs or any LLM for text generation task, as input sequences that exceed the maximum token limit will be truncated or split into multiple segments for processing. Exceeding the token limit can also impact the quality and coherence of the model's responses, as it might not have sufficient context to generate accurate and meaningful outputs. So you might get something completely out of context if the LLM runs out of tokens to generate. And that's something we have to play with it to kind of like have it, get used to it. And that's what we are going to go to that playground. It's worth noting that different versions of GPT models, model series may have different token limits, of course, and OpenAI may adjust its limits over time based on factors such as model architecture, computational resources, and performance considerations. Therefore, it is essential to refer to the latest documentation and guidelines provided by OpenAI for the most accurate information on token limits for specific versions or the GPT model series, and also pricing. Pricing is something we don't have to discuss now because we're going to go to the playground, and when we build the applications, we're going to use the free tier, but later there is a pricing model that we need to also be aware of. So we can go to this link here to see the latest documentation, and in there it will give you the up-to-date list, not just GPT 3.5 Turbo, but it will give you GPT 4 and whatever other models might come in the future. So always look at your most recent documentation. Last, we're going to see the temperature. So in the context of language generation models like GPT, temperature is a hyperparameter that controls the randomness and diversity of the generated text. When generating text, the model assigns probabilities to each token in the vocabulary, representing the likelihood of selecting that token as the next word in the sequence that it generates. The temperature parameter adjusts the distribution of these probabilities before sampling the next token. A low temperature value results in a more deterministic and conservative sampling approach, where the model tends to select tokens with higher probabilities, leading to more predictable and repetitive outputs. Conservatively, a high temperature value increases the randomness of the sampling process, allowing the model to explore a wider range of tokens and produce more diverse and creative outputs. In summary, adjusting the temperature parameter allows users to control the balance between generating conservative, high probability text and generating diverse and creative text. And we're going to play around with the temperature in the playground, where we're going to jump in right about now. So it's time to build some AI applications. Let's go to the playground and play around with some prompts, and then we're going to continue building some more applications in another video. Let's exit this and go to this first link, which I'm going to leave in the video description, where we have the list of different models. We have from the bottom, we have GPT-3 Turbo, DALI, which we're going to see. We're going to build a application with that later on. But in here, we can see that GPT 3.5 Turbo, this one is legacy. It's, well, let's go and see this, maybe the newer one here that we can use, or maybe this one here. So currently points to GPT Turbo. There's some description here. Then there is a tokens, the amount of tokens that we can generate, and is up to this day here, September 2021. So the limit for this model would be 16,385 tokens. Depending on the free tier, we might have access to a GPT 3.5 Turbo, or maybe a different one, and this could be different, which we're going to check later when we go through the API documentation. If you're using GPT-4 and you're using the latest one, you have 128,000 tokens available to generate some outputs. So depending on the LLM that you're using, this could be more, could be less, or it could be about the same if you're using some of the latest ones. Now we can jump to the playground. In the playground, there's a link in the description to go in here. We can, in here, I'm already sign up and sign in. So if you have an account, you can just sign in to the playground, or if you use brand new, you just sign up with your Google account, or any other options that they provide. In here, we have, make sure if you're in the playground, you select the chat in here. In order to work on that, we are going to work with chat for now. And in here, to test it out, in the left-hand side, you can tell the LLM to take a persona. So right now, by default, it's going to be your helpful assistant. And here we can type some prompts in order to get an output. On the right-hand side, we can select the model that we want. We can select the temperature. So this is going to control the randomness. We're going to control the max length of tokens. And then we have step sequences, which we're going to see later. Tab P, which we're going to see later. And then the frequency penalty, presence penalty, which all of these we're going to play with this later when we work with the API. For now, let's prompt the LLM or the GPT with a short prompt. Let me just grab it from here to save some time. So here we're going to take the LLM to write a short story about a software engineer who is also a part-time superhero. And then we're going to hit submit. And we're going to get a short story. Sam was your typical 9-to-5 software engineer during the day, working on coding and debugging programs for a large tech company, but in the nighttime. But when the night fell, he transformed into a different kind of hero, a mass vigilante known as Batman. So here we got a short story. If you notice, the story was kind of like cut off here. So that means we'll probably run out of tokens in here. So we could increase this to maybe, let's say 597, and let's run the prompt again. I'm gonna paste that again, and I'm gonna submit it one more time. So here you might get a different story, and this is because our temperature is kind of like right in the middle, so it could be different outputs, could as well. So here we have Alex, software engineer, and he's transformed into the binary Avenger during nighttime. So here we see that I think it was able to complete the story. I'm not going to read the whole story, but it looks like it was able to finish. But because here we didn't have enough token, it couldn't finish the story. And you can see some text that is not even readable down here. Now, this will work just fine if, you just, we don't tell the LLM to take any persona, like you are someone else, but we could tell the LLM, let's say, to take on the persona of a data analysis. And then we can tell the LLM to write some SQL for us. So here I'm going to add a new message, and I'm going to hit submit. So here we tell them you are a data analysis, and we're writing you are write a SQL query to list all names of employees sorted by the department. So here we get SQL select name from employees ordered by department. Pretty simple, but we could also tell the LLM to who they're supposed to be. So we can tweak the persona of the LLM. Here we have some information about the SQL query, and if we have, let's try to do it again with more tokens here, and let's try to paste it again, see what happens. We get pretty much the same output here, which is fine. Let's try another one. Let's say now the LLM will be a web developer, and we want the LLM to write a basic landing page layout for a music streaming website, or anything that you want to try. We're gonna hit submit, and right now I have 1002 tokens, and it was able to finish the landing page for us. And you can see it gave us some HTML code, and we have this 3 backslashes surrounding any code that the LLM provides. We have the head tag, we have a title, an H1, a section, a hero section, a key features, and a few more footer and basic code, which is nice, right? We can create that. We can also tell the LLM to generate the CSS as well. And we got to make sure we have enough tokens as well. We can try that really quick. We can paste it in here again. And we say write a basic landing page layout for a music streaming website. Let's say give me the HTML and CSS code. Let's see what happens. Let's increase the max length to 2000 and send it in there. We get the page, and we get the HTML code as well. Pretty cool. Now let's do one more. And we don't always have to set the persona here. I'm just showing you different ones. So let's say in this one, you are an IT expert, and we're going to write some prompts that maybe someone can be typing into a chatbot. So let's say we want to say, I can't see anything on my monitor. I hit submit. And right now, this is not giving me what I want. I apologize for any inconvenience. Seems like your formatting might not be displaying the correct content on your monitor. Oh, okay. So it's still thinking that we're still in the same conversation here. So we could refresh this here, so we can start fresh, and then we can paste this again, and then we can just write it in here. And these chats, I don't think they save, but later we will be able to save them and see how all the different options work. But let's just do, let's say I need help resetting my password, and hit submit. And here is, sure, I can help you with that. What are you trying to reset the password for a specific website or application? If so, please provide the name of the website or application, and it starts the conversation for you. Let's just try to change the topic. You can say, maybe you can help me with my PC, which is running very slow today. Something like that. And then it's going to respond, sure, I can help you with that. And then it's going to give you a few things to try. Check for malware, check this, and it's going to continue the conversation from there. So this is looking at the different personas, different conversations you can have. I'm going to refresh this really quick and go back to our superhero story here, just so we can play around with the temperature or the randomness. So if we leave it at, let's say 500 tokens, hit submit, and let's see what story we'll create now. Right? Okay, didn't finish the story. It will probably need a few more tokens there, but we're going to, let's say if we change the temperature, let's say let's increase the temperature to 1.3, around there, and let's try to submit this again. Let's increase this to 800, paste it again, and let's see what story comes up with now. So if you read the story, it might come up with a more fun or more weird story than before, because we're playing around with the temperature. And in here, we'll have to read both stories to see how different they are. But we can also do a simple query prompt that can just provide something smaller that we could read. But if we read this too, this one should be more of a creative story than the previous one. And playing with the temperature to get the output that you want is something that we need to play with when we prompt the LLM later on during building our different applications. These stop sequences, you can set use the stop sequence if you, let's say we go back to the data analysis prompts here, and then in order to give you a quick example, let me just add this here, and then I'm going to have a semicolon here to tell the LLM that when it sees a semicolon, it needs to stop generating text or content. So I'm going to hit submit. And if you notice here, your SQL statements, they always end with a semicolon. So here, as soon as he encountered that semicolon, it stopped. Before it got all the way to the end, it gave us some information about the query. If we remove this and we run that again, it will go all the way down, and when we saw the semicolon here, that's when it stopped. So for now, this is a playground where you can go and play around on sharpening your prompt engineering skills. And when we jump to the next video, we're going to start building the applications. We're going to use the API or the OpenAI API to start building those queries. And the cool thing about the playground, if you look here, it says view source, view code. If you click there, it will give you your code in order to end the conversation, the messages that you generated. So this is all the ones that we have from before. And then here you could change a different programming language if you want Python, if you want Node, and you can start with this in your application. But we'll work on this in the next video. I hope you like this one. I'll see you in the next one.